So this is kind of the talk that I was going to write. I gave a title and description that it kind of fits, but when I started writing the talk, it kind of went in a slightly different direction, which kind of happens sometimes. I'm going to talk about systems, not about software. I want to make this clear because you're hearing a lot of talks about software. You know, how to write the code, how to make the code go from point A to point B, and all this stuff. And I personally hate software. It's kind of the worst. I think that this is a pretty good set of mottos when it comes to code. The best code is always no code at all. If you can achieve your goal by writing zero code, that is the best, because all code is technical debt, honestly. Sometimes it's an investment, sometimes it's a subprime mortgage, but it's always something that you're committing to maintaining, and that sucks away your life force, and you should have as little of it that you are personally responsible for as possible. Every senior engineer knows this. As a senior engineer, you know, to me, it definitionally means that you have graduated from simply writing components, and you've begun building systems. Your job is not writing software. Your job is building and tending and maintaining those systems, and passing them along to future generations, making them leave your hands in a slightly better condition than they came to you. All this stuff, and every system has a purpose. Sometimes that purpose becomes self-referential, and those are the worst systems of all to work on. Leave them. I do just want to call it, it's important to believe in the purpose that you're building the system for. We have a very powerful skill set. Lots of us are using these skills to build systems that maybe shouldn't exist in the world. So just a thought. Software is a very powerful tool, but it's only part of the puzzle, right? Lines of code are like children. You give birth to them, you own them, like it or not. Yeah, I don't have any of my speaker notes. I feel like I wrote a whole essay about this, but I'm just going to leave it at that. We are getting better at building software over time. I've been on call since I was 17, and when I look at the stuff that we used to build, we've gotten better. This is great. Unfortunately, we're getting better about like this, and like complexity is going about like that. So we're not getting better fast enough. We're outpaced by demand and complexity and the compound effects of all of these accelerating forces. And it's Moore's law all the way down, of course fed by the gaping, demanding maw of human demand for novelty and features and shiny, faster, pretty, all this stuff. It's pretty fun if you like train wrecks like I do. You probably do because you're here. That said, we have to do better. And I want, if you haven't seen this report from Stripe, there's the URL. I recommend spending some time with this. They surveyed thousands of developers, and they found that bad code costs companies $85 billion every year. Developers around the world create $3 trillion worth of value added to the GDP every year. And about 40% of their time does not go to adding value. It goes to technical debt and bad code. And then they go into details about what they mean about all this stuff, but if you sit with that, there's some hard truths there. Around build versus buy, around novelty versus stability, around lots of stuff. I recommend taking a nice stiff drink. And the way you serve them here in Europe, I'd say 3 or 4 stiff drinks and just sit down with that. Cool. We got to do better. So, oh yeah, here's my intro slide. I've worked for these places. There's my blog. I wrote the database reliability engineering book. If any of you have it, I don't know if you know this, the cover's broken, meaning O'Reilly doesn't let you have mythical creatures, so we had to pick a horse. But I have stickers to fix it into a unicorn. So see me after class if you need one. And Honeycomb is the company that I started. It will be 3 years on January 1st. And Honeycomb grew out of deep pain, let's say, particularly on parse. If we have time, I'll tell that story in a little bit, but I'm going to scooch along. And I am very endeared that you guys keep inviting me back to these serverless conferences. I was there at the very first one, and I walked in, I was pissed off, and I was like, no ops is a lie, or at least, no, it's at least as much of a lie as no devs. Like, what? In the future, we aren't even going to need developers. It's just going to be like gluing together APIs, and any asshole can do that. So, but like for the first couple of years, I was just like, yeah, you own your uptime. You can't outsource it. I'm waving my cane. Whatever. Thanks for having me back. I always find it really fun to come talk to you. So now I've graduated from yelling about uptime to yelling about systems. And to me, systems are comprised of basically these 4 components. The internal and external components, this is the software, right? It's software running on infrastructure. The interactions and connective tissue between the components. The people who work on the system, their habits and practices, and the users. This is the thing that people always forget. They forget the users, who are the ones bringing their request patterns to you and shoving data at you. Sometimes, if you're building a platform, they're even uploading their own shitty code to run on your services. Super fun. I want to start by quoting Lidenby, who has this great talk about understanding systems that you should all go look for. He says that much of engineering leadership is becoming about explaining our systems to the rest of the world. Raise your hand if your mom knows what you do. Yeah, right. Exactly. I'm like, Mom, I do virtual currency and blah, blah, blah. And she's like, is that real? People give you money for that? They're finally realizing that software is eating the world and they don't really understand it. We've sucked at this, and so the government is beginning to force our hand in ways that we grump about. But what we should be hearing is not, oh, these people who don't know anything about software coming and regulating us. We should be hearing, we have done a bad job of this. We have done a bad job of explaining our systems, and spoiler alert, it's because lots of us don't know. We don't honestly know what our systems are doing. It is way harder to understand a complex system than to build one. Any jackass can build a complex system. Not any jackass can understand that complex system that has been built. So before we get to the stuff about observability and how to mitigate all this stuff, I think it's important to line up incentives correctly. Because if you don't get the incentives right, none of the technical solutions are going to do shit. So to me, this starts with software ownership. And to me, I think there's 3 things. That the people who write, and this is not, I'm not prescribing any model for this. There's lots of ways to implement this. All I care about are the incentives. And to me, it seems crystal clear that the people who write code should be able to deploy that code and roll it back. And they should have access to debug it on live data, running with real users in production. Because if you tear apart this feedback loop, this virtuous feedback loop, well, let's look at what happened. In the beginning, there was prod. And engineers are just sitting there typing on the prod box, writing code and shit, and users are like, oh, this isn't working. They complain to the engineers, get them to fix it. And there's something magical about small amounts of pain applied strategically to people who can change things. Our systems got a lot bigger and more complicated from there. We started to have different teams, dev and ops and all this stuff, and we broke that feedback loop. And we broke it, so all the people who were feeling the pain weren't the ones who had the context in their head about what had just changed. So they had way more pain, so they became masochists. Recovering. It's been bad, right? The entire DevOps movement was basically, I guess, the New Testament in my metaphor. That got weird. It's basically a way of reclaiming that virtuous feedback loop. Because if the incentives are such that the people who are feeling the pain don't have the power or the ability to make the fixes, you're just going to have unbounded amounts of pain. And once you have unbounded pain for years, compounding on itself, nobody's going to look at that and be willing to be on call for that system. Legitimately, especially those of us who are over 30 and can't get back to sleep anymore. Nobody wants to be on call for that, and I don't blame them. So, nevertheless, I've gotten pretty hardcore about this. This is a social contract of software. If you do not want to own the quality of your software, sometimes around the clock, go get a job writing some other kind of software. There are those jobs. They exist. But if you want to work on a highly available 24/7 service and not ever have to have accountability for your own code, you're just saying that someone else has to do that for you. Someone else has to be your whipping boy, to sit there take the licks. That's not okay. And the corollary, of course, is that on-call can't be miserable. It can't be something that impacts your life, that really, that you dread. And this is doable. People doubt me when I say this, but my team, we have a very fast-growing platform. They get woken up once or twice a year. It's a bad week when they get paged. This is absolutely doable. It's not easy to get back to that state once you have, piles of debt, but it actually happens faster and easier than people think once you have management buy-in and engineer buy-in and everybody's on the same page because the results are so tangible and so huge and so meaningful that it's very motivating. I mean, who doesn't want to pay down technical debt? That's our favorite thing to do. It is harder to understand complex systems than to build them. And so understanding them starts with the building part, right? I think of it as the successor to TDD. It has to be ODD. Because tests stop where your laptop ends, right? They're no good beyond that. And all of the interesting bugs are never going to get caught by your tests. Tests are kind of like monitoring checks. They're great for the known unknowns, the problems you've already seen, the ones you can guess are going to happen, and the really, truly dumb shit. And that's about it. And by observability-driven development, I mean basically that, obviously you get your code out into the real world as quickly as possible after you write it, while you still have all that context in your head, and then you look at it. Like muscle memory. Did what I just ship do what I think it does? Does it do what I meant to do? Does anything else look weird? 80% of bugs, users would never even see them if you just get used to looking at your stuff. And you'll get used to knowing what production looks like when it's not on fire. So there's two different kinds of knowledge that people have here. There's the knowledge that is the intention of the author, and then there's the knowledge about the actual behavior. And obviously, knowledge about the actual behavior can get tacked on for the life of the code. But nobody is ever going to have knowledge of your intention. And you're going to forget what your intention was in 2 months, tops. So I think it's really important to capture it and to check yourself as you're rolling it out. So what is observability? And this is where people are like, isn't that the same as monitoring? And it's totally understandable that you would say that, because every vendor on the planet has a very big financial incentive to make that the default definition. But it's not. Definitely not. Monitoring is the action of observing and checking the behavior and outputs of a system and its components over time. Monitoring systems really haven't changed in 20 years. The dashboards, the checks, the metrics as a data type, they've gotten shinier. Hasn't really changed. I love using this slide because this guy he gave this talk at Monitorama and then immediately went to be the VP of a monitoring company and started getting really mad at me for quoting him, so now I quote him everywhere. I'm a dick. But observability in control theory, it's a real thing. Now, I'm a music major dropout, so I never learned this in school. But I learned it on Wikipedia, so it must be true. It's a measure of how well you can reason about the internal state of a system by having knowledge of its outputs. For software, when you imply this to software systems, it seems clear to me that it means, can you understand what's happening inside your systems from the outside, not by SSHing in and running S-trace, like you could. I mean, this is serverless. But usually everybody is like, oh, isn't that a tool? No, that's not your tool. Your tool is your instrumentation. That's all you get. And God bless serverless, because now when I'm trying to explain this to people, I can just go, like with serverless, right? And they get it. But instrumentation is your only tool, and you actually don't care about the health of the service at all. The only thing you should care about is the health of every end-to-end request as the user's request makes its way through your code. If it can get the resources that it needs to succeed, great, your job is done. Leave the rest to the infrastructure people, like me. Ops is never going away, right? But we're increasingly going to live on the other side of an API from you, which is part of the unbundling of roles here. But can you debug your code and your systems? Can you answer any arbitrary question, whether you predicted it or not, just by asking questions from the outside? And can you answer them without shipping new code? It's easy to answer a new question if you ship new code. That's cheating. It's instrumentation based. It is a perspective shift. It's about, like monitoring is very much, it's a third person perspective. You've got one piece of software checking up on another. How's it going? How's the threshold? Are you healthy or not, right? Observability is about getting inside the head of the software and helping it explain itself back to you or your team. Modern systems are becoming so complex that they exhibit emergent behaviors that we can't predict. So it's not our imagination, right? That these systems are getting a lot more complicated to understand. They're becoming like living systems with emergent behaviors. And if you look at some architecture diagrams, it becomes pretty clear. Here's the humble lamp stack. And I always tell people, if you can solve your problems with a lamp stack, please do. Please, for God's sake, just do. But many of us can't anymore. This is Parse's infrastructure a couple years ago. Then in the middle blob is like several hundred MongoDB replica sets with co-tenancy problems because we just let developers all over the world write their own queries and upload them, and I just had to make them work and not affect anyone else. Same with JavaScript. Just write the JavaScript, and I don't care what it does. Like, just make it work. Ugh, never do this. It's great for developers. Terrible for us. But that over there, that's the National Electrical Grid, obviously. And that's really the kind of model you should have in your head for thinking about these systems. Vastly distributed, made up of lots of parts that don't really know about each other. Some problems are going to be hyper-local, like a tree falls over on Main Street in bumfuck Iowa. Couldn't have predicted it. Shouldn't really try. You should just get good at healing it when it happens. Some problems are going to be the opposite of that. You can only find them when you zoom way out. Like if every bolt manufactured in 1982 is rusting 10 times as fast. It needs to be replaced at a different schedule. And like every layer of abstraction in between, right? And the important like attitude shift that goes along with this is just, things are failing all the time. It's fine. It's totally fine. In fact, it's bad if things aren't failing, because you will forget how to deal with it. You need constant practice. You need to be thinking about resiliency and just like having a sense of humor about it instead of trying to keep it from, falling. Like, I don't know if you've been following in the States what we're dealing with wildfires. Well, for years, they were just like, wildfires are bad. Nothing can ever burn. We're just going to like, so what did they do? Well, they built up lots of tinder is what they did. Now the wildfires are like 10 times worse. They didn't let the resiliency of the system kick in. So it tracks like known unknowns. Like you can look at that system on a dashboard and immediately identify where the problem's coming from. You can use your intuition and a couple dashboards and just, you're a superhero. You can explain everything. Here, you've got a system that's looping back into itself over and over. Any single node can, in theory, infect the latency of the entire system. So this is where the shift from monitoring to observability comes in. Observability is about capturing data at the right level of abstraction so that you can reason about your systems and ask new questions without shipping new code. This is kind of a weird thing for ops people, especially to wrap our heads around. But it's just like, I don't care about the health of Amazon systems as long as my code can run, right? This is probably second nature to you. This is also interesting. There is one of the other warring camps over observability is the folks who are like, there are 3 pillars of observability: metrics, logs, and traces. For no other reason that I can come up with other than that like companies seem to have had metrics, logs, and traces. I honestly don't even understand the argument. In fact, all of those data types are basically outdated. And what you want is a structured blob that tracks, throughout the life of the request in the service and just accumulates detail as it goes. Like any detail about, the context, about any calls out, right? Any queries, you would store like the latency of the query, the full query, the normalized query, user ID, shopping cart ID, like any unique ID, because high cardinality is so important. When I say high cardinality, I mean, imagine you have a table of 100 million users. And the highest cardinality would be any unique ID, social security number, request ID. Quite high cardinality, but slightly lower, would be first name, last name. Gender is low cardinality. And presumably species equals human is the lowest of all. just guessing. But when you look at these types of information, what's going to be useful? It's all the high cardinality stuff because it has the most identifying information. And yet, metrics cannot handle high cardinality because it's a number. It's a single number, and then you append some tags so that you can group your metrics up. But due to write amplification, those can't be high cardinality. So if you Google for this, you get a lot of information and helpful tips for how not to have this problem, which I think is a total cop-out. You need your high cardinality dimensions. You need as many of them as possible. And you need them to be organized around the unit of work that is the request per service. You also can't get to observability with anything that is messing with your raw requests. Anything that's doing write-time aggregation, anything that is doing any sort of pre-processing, even indexing is highly suspect in my view, because you need to be able to run ad hoc questions, right? So anything that is doing something predictive about the type of data that you're going to need to fetch is guessing and committing you to a set of questions that you can ask in the future. So you have to, so like Bo in his great talk recommends rolling out structured events to something like Glacier forever. It's cheap, it's pennies, just like keep it there. And then you're gonna want something queryable so you can actually deal with it. Some queries won't take a day. I could recommend Honeycomb, but I'm a vendor, so you shouldn't trust anything I say. Anyway. The first law of distributed systems, though, is that your system is never actually up. If you're lucky, it may asymptotically approach being up, but more likely, if all of your monitoring checks and everything is just green, it just means your tools are pretty bad. There are so many problems in your system, like right now, that you have no idea about. And in fact, like when people are doing trials with Honeycomb, one of the biggest problems we have is that people start finding those problems. And then they stop their trial to go fix them. And we're just like, no, that's been there for months. Just let it go. It's very frustrating for me, personally. I'm like, there's hundreds more where that came from. They don't find that comforting. But instead of having like a few checks that you can run against your systems, distributed systems basically just have an infinitely long list of things that almost never happen. Except once in like 10 million times it does, or 10 million impossible things happen at once, but at Facebook scale, that's like many times a day. And this means that staging is basically useless. And all of the engineering time that you're sinking into it is just a write-off. Which is why I believe in testing in production. Now, it's got a bad rep, and I basically blame this dude. Like, it's a great meme. It's a great meme, but it has this false, like, it sounds like you can only do one or the other somehow. And I would like to suggest that you can, in fact, do both. You can run your tests, to catch the basics, and then you can stop there and, invest the rest of your precious engineering cycles into hardening production, into making it more resilient, into your tooling, into, because all of the time that you spend staring at your laptop or staging or any false environment is a net loss, honestly. You should all want to be spending as much time looking at the intersection of your code with the real environment as possible for you and everyone on your team. And for the people who are like, oh, but highly regulated environments, bullshit. That is a cop-out, because we're talking about operational data, and that's not PAI, that's not PHI, that's not highly proprietary. That should never be in your operational data. Fix that problem first if you have it there, so that you can put your engineers' eyes where they need to be, which is on production. I could rant about this for quite some time. But the key kernel of truth here, whenever anyone starts to protest about it, that you have to circle back to is just the fact that you can't avoid it. You cannot you can't test everything. You cannot possibly test everything in a false environment. Even if you do capture replay, which is the gold standard of testing, right? And I've written this piece of software 3 times because I come from databases, right? And data is where you need to do this. I capture 24 hours worth of traffic, spin up a copy, and replay it, and replay it, and replay it, and replay it, and replay it for like a year. That's scar tissue, never mind. That's the gold standard, and you still can't, it's still not going to give you the assurance that you seek, because that's yesterday's queries. Tomorrow, maybe Michael Jackson's going to die. You know, you can't predict it. And every time that an artifact goes to an environment, to a point in time in a system, is unique. It is irreducible. Only production is production. There's so many risks that you can't eliminate. And the more time you spend trying to stave off those failures, the more your brain gets like invested in the idea that that's worth doing. It's not. Just give up. Go home. I feel like this should be a happy message. Engineering cycles are your absolute scarcest resource, as that Stripe survey said. And it's limited, right? So the other key fact is not that there is no value to staging. Well, I might say that. Well, but you don't have to believe that there's no value to staging. That's fine. The point is, I guarantee that none of you are investing as much of those cycles as you should be into production. I've never seen a company at the mid, sub-Facebook size. I've almost never seen a company that invested enough into the tooling of shipping code to an environment. People put their fucking interns on this. Deploy software is it is the redheaded stepchild that we kick around. It's like, just do it in your spare time. You don't need to code review that. Give it to the junior one. No! No! Give it to your senior engineers, if for no other reason than to signal that you value it. It is incredibly important. The process of shipping code is where most problems happen. Also, get your designers involved. Make sure that the right thing is the easy thing, and the obvious thing, and the human thing. And the hard things are hard, but there's friction there. I'm not good at that. I'm not good at that at all. My shell scripts are highly fragile. Designers are very good at this. And while I am a big proponent of buying instead of building, those are components, right? And you're always going to have to glue them together for your particular environment. And that glue code is probably the most important code that you have. So if you think you don't have any cycles to spend on them, may I suggest taking them away from staging and giving them production. Okay, I'm about ready to get off this horse. I have some cute memes for you because I don't want to just be ranting at you. But also, talking about testing in production, some people seem to take this as a license to care less. I'm not saying cowboy it in production. I'm saying invest in it. Invest in it and educate your team. Make sure that everyone knows how to get the system to a good state, right? Or back to a good state. Make sure people don't feel like it's foreign to them, like it's terrifying. The whole BOFH thing where you wanted people to be afraid of production. No, you don't. People freeze up and they make stupid mistakes when they feel scared. You want them to know what they're doing so that they know what is dangerous. And so you've designed the system so it's hard to do dangerous things. And you want them to be in there every day looking at the consequences. What is happening when the code they wrote met reality? So why is this happening now? But it's really just, it comes down to complexity, right? And here's my music major dropout graph. I have a graph, so you know it's true. But complexity is definitely increasing, and it's going to be basically impossible anytime soon. We are all distributed systems engineers, and distributed systems are incredibly hostile to being cloned or imitated or monitored or staged. So many of the bugs that you have are only going to come out at certain high concurrencies, or and nobody is going to pay for anyone to spin up a copy of Facebook, let alone a copy for every developer, right? All right, this is a repeat. This is some real science, though. Katie gave a great Papers We Love talk about staging environments and tests. And it turns out that there's math that supports the fact that you can catch 80% of the bugs with 20% of the effort. So that energy is better used elsewhere. We need to watch your code run with production scenarios. Here's the slide I was looking for. There we go. So our old view of development and prod was very bifurcated, right? It's Well, over here, we're like completely isolated from the real world. Then we flip a switch, and suddenly it's all production. And test before prod. This is basically, for software engineers, the equivalent of monitoring checks, right? It's all your known unknowns. Does it work? Does my code run? Does it fail in ways that I could predict trivially by looking at the system? Does it fail in ways that it has previously failed? I am a big proponent of it should only be an engineering problem the first time it happens, right? The first time anything happens, it's new. It's hard because it's new. It will take an unknown and possibly infinite amount of time to figure it out. It's just how it is. It's an engineering problem. That should only happen once. All future encounter, it would be nice to say that it's possible to just every time a problem happens, we make it so it never happens again. Okay, we know that that's not actually feasible or reasonable. However, we do need to move those problems from the engineering pile over to the support pile, where the support pile does not take our creative juices. It is pure pattern matching. It can be done by non-engineers. That's the goal. And we test in prod, well, basically everything else. Things that need to be done at scale. Experiments, A/B testing, behavioral tests. I know of a couple people who literally, they run a constant 20% load test in their systems. So anytime they run out of a resource, they just turn off the load test. It's great. Canaries are really your best friend here. Multi-region stuff. So Facebook invested really heavily into canaries. They spend a lot of time investing it so that a developer can just deploy a binary to a host and watch it for a while, because it is effectively impossible to debug most problems at Facebook any other way. So they'll have hundreds of versions running in production, and it's fine. It's not actually chaos. And the process usually goes it makes its way through the sandcastle, the automated build pipeline, and then it's ready to be promoted. So they'll promote it to one machine. And then when it's ready to get in the real queue, it'll go to everyone internal first, right? The internal Facebook domain. So if we have to use Facebook for work, but if Facebook for work goes down, well, that build clearly wasn't fit to survive the evolutionary challenges of reality. And after internal, it goes to 10% of Brazil. And why they pick on Brazil, I have no idea. But it goes to 10% of Brazil, and then 50% of Brazil, whatever. And then they go country by country or region by region. It takes a long time to get out. And what you sacrifice here, obviously, is immediacy for resiliency. And early on, it's not worth making that trade-off. But later on, it definitely is. Also build or use feature flags, high cardinality tooling, canaries, shadow systems. By shadow systems, I mean, we built one of these for the rewrite of the API from Ruby to Go, because Ruby had all of these awesome assumptions about type, and Go had none of them. So we built a little splitter shim, right? So the load balancer would send requests to the splitter. It would fork it. It would compare the results between the old API server and the new one, and then print out the diff. So engineer could go check it every day for any differences. Super valuable. And then later on, we changed them for data mutations, where the splitter would hand off to another splitter that would split between nodes that had production copies of the data versus snapshots of the data, and they would diff them. And I said build or use, but please don't build your own, please. I would like to feel like we're past that as an industry. Like I said, I've built this fucking capture replay thing 3 times. It was worth it the first time. Should have open sourced it. All of these things help us be less afraid. And I don't know how much codependency problems matter to you folks, but for platforms, another thing that people just don't invest in enough are ways of cordoning off any way that we've partitioned up data or users or services or anything, so that the 99% of users who are using your platform in a reasonable way are not impacted by the few who consistently don't. The jerks that just 5x full table scan looks fine to me, ship it. You need to be able to very rapidly just no. draw a line, right? Whether it's by shard, by database, by table, by user, by group, by shopping cart, by region, by like any way that we've like built these like horizontal, these partition distributed systems, you need to be able to like, even down to like rewriting queries in flight. I fully believe that we do not invest in these enough. Because that is the difference between reliability for your reasonable customers being very high and everyone coming down to the lowest common denominator. Anyway, in conclusion, what could go wrong? Well, everything. Actually, failure is not rare. Us noticing the failure is somewhat rare because most failures do not actually surface up to our consciousness. We can't afford to have, like we set thresholds, let me know if it gets this bad, and then I'll go deal with it, right? We can't afford to get paged every time that a bug gets hit. That would be insanity. So I don't know if this is the best strategy for convincing your management chain, but it's reality. So take that and do something better with it. You all need to practice shipping and fixing this stuff. This is not just a job for ops. It's not just a job for the 1 or 2 people on your team who are good at it or who like it. This is an absolute necessary part of being a software engineer for the next decade and beyond, is owning your code, owning your systems, understanding how, you don't have to understand everything, but you need to be fluent in the tools that let you have a debugger's mindset. Everyone on your team should know what normal looks like. They should not just look at their systems when they're down, or when they're broken, or when there's a bug, or when somebody escalates to them. If that's when your team looks at stuff, you know you have work to do. And that's probably most of us. Still, aspirational. That's why you flew me over here. Does everyone know how to roll back? Does everybody know how to explore? We can't just take a run book and a dashboard in our systems anymore and just like pattern match and fix, right? All of those things have been automated away or will soon be automated in the future. In the future, every time you get paged, it should be something that is an unknown that has never happened before, that confuses the hell out of you, which is great. These are fun, right? Nobody gets annoyed about those, like, because we get annoyed about the ones that are, oh, that again, right? That's the bad stuff. The good ones are that, oh, this requires my engineer's brain to figure this out. This is fun. This is a puzzle. Anyway. Tried to rewrite some memes here. Instead of testing in prod is bad, not having tools. Test your code in production. And in conclusion, systems exist to serve a purpose. How do you feel about yours? I have worked on systems before where I felt better about the world when they were down. I will not take those jobs anymore, and I wish that I had had more confidence at the time to just walk away. I stayed, two jobs I've had, I stayed for a year and a day because I felt obligated to. I felt like I would be a bad employee if I left, and I hated it the entire time I was there, but I stayed, and I shouldn't have. There are times in life when we have to suck it up and work places that we don't, for whatever reason, we're compromised. This is a capitalist society. We've got to make money. We don't always get our first choice. But in this industry, for everyone in this room, you can get another job. You can get a job that you believe in. You can build a system that you think should exist in the world. So, quit, please. And my final meme. Thank you.